Hello guys, this is Om and welcome to Civil Raja, your gateway to future. So guys, I was just scrolling over the Google and I came across a news. So I'm just going to share that news with you because that is not a very good news. So I will just take you over there. So guys, the news was Noida viral video, 4 people dead as 100-meter long boundary wall of housing society falls off. Okay, then we also have this video where you can see that these people are helping to clearing out this space where the boundary wall collapsed, and 4 people are dead in this one, and 8 of them are rescued. So on total 12 people were around the boundary wall when it collapsed. So it created a lot of damage, and this is just sad news. Now, being a civil engineer, I try to figure out like what can be the possibilities of breaking or collapsing of this boundary wall, and I have figured out 7 possible mistakes why this boundary wall collapsed. Okay, so I'm just going to talk each and every mistake over here. And guys, if you're new to this channel, then subscribe to Civil Raja and also like this video and share it as much as you can. Okay, now I'm just going to show you what I have collected over here. So guys, you can see this was the picture taken from the site itself, and now what can be the possible reason. So first of all, let's understand what is the situation over here. First of all, you can see that this is a brick wall, right? So whenever you are creating a boundary wall, where you have to go for filling, like on one side you can see we have soil over here, on the other side it was completely vacant. So obviously a soil pressure was created on this boundary wall, and it led to this breakage or collapsing of this boundary wall. Okay, so we have to go with RCC walls in that case instead of this brick wall. Now, whenever you have to just make the boundary wall using the bricks, then you have to consider the foundation depth also. So normally what people do, they usually go for a foundation depth of 3 feet. Okay, but that should not be the case. Okay, the foundation depth, if you're going for a brick wall, that should be minimum of 6 feet for isolated type of footing. Okay, so I'm sure that this was a housing society, so obviously the columns and the foundations were good. But whenever you have to fill the sand on one side, you should have gone for the RCC wall, which is mentioned in point number 6 over here. That is brick wall instead of RCC wall was used in this boundary wall. So we must use the RCC walls if we have to fill the soil in one direction and another direction is completely vacant. Okay, then uh, the second mistake over here, that is the possible mistake over here, is the lapping of the steel. So whenever we have to lap the steels, then what normally the people do, like they will start lapping in this way, like 1, 2, 3. Steel rods are there, then we have to make the laps. So what they will do, they will just do it like this. Okay, they will simply create the labs like this. So what is the wrong thing in this one? That all are having left at a same height. Okay, that should not be the case. Okay, whenever we have to make some labs, we have to always move in this manner. Okay, that one the length of the steel will be longer, then the adjacent length will be shorter. So the lap will be made like this, then this. Okay, and the another adjacent lap will be like this. Okay, so this should be the scenario of the lapping instead of this one. Okay, so that is also a possibility why this happened. Then the third possibility can be concrete vibrator wasn't used normally. Whenever you will see that as you can see in the slide, or you can say in the news, it was a 25 years old war. Obviously back then vibrators were not very much in use. Okay, for the normal work. Obviously, for the high-rise buildings, they were being used. So concrete vibrators were not used, then the columns are not properly casted, the beams are not properly casted. So even that leads to the reduction of the strength of the columns and the beams. So that can also be a cause of this one. Then fourth number is the number of tie beams. Okay. So what will happen with the tie beams? Okay, so normally whenever you'll see that we have a boundary wall, it doesn't matter how high it is, they will just create a beam at the bottom, one at the top. But that should not be the case. Even if it is a boundary wall, you must provide the beams at every 5 feet height. Okay, like suppose you have a wall like this. Simply, let's say you have this rectangular wall. Okay, this is the wall that we have, and this is a 15-foot high wall. Okay, so the total height over here is 15 feet. 1 5 15 feet. Okay, now you have to make a beam over here, then another beam over here, another one at a 5 feet of here, and then one over here. So on total there will be at least 4 beams over here. Okay, so these can be the tie beams over here. Then the fifth possible point can be the wind load was not considered. Okay, so you can see wind load not considered. So what will happen in this case is, suppose you have made a 15-foot high wall and you have filled the soil till 5 feet, but the wind pressure is being acted on this rest of the 10 feet. So that load should also be considered. If suppose it is a like a closed area, like we have a multiple like buildings over there, then you can avoid this, because above 10 meter you have to consider the building load, below 10 meter we do not have to consider the building load. But suppose you are like making this boundary wall in an open area. Okay, so whenever the storm will come, the wind load will act on this portion of the rest of the 10 feet. Okay, in the like bottom 5 feet, the soil load is already exerting its pressure, and on the top 10 feet the wind load will exert its pressure. Okay, so wind load may not have been considered in such cases, because normally whenever we are creating some housing colony, we consider that okay, uh, mm, meanwhile, like in few years, another few houses will be constructed, and so this will not affect the like wind load will not be acting upon our boundary walls. So this is a normal conception that is being used, but in your case it is not the it may not be the possibility. So this can also be a possible mistake, that okay, wind load was not considered on this one. Then sixth point, as I have already discussed this, a brick wall was used in instead of RCC wall whenever we are making the boundary wall with one side as uh, on one side we have the backfilling as the soil, then we must use the RCC wall instead of brick wall. Yeah, if you are having no load on any of the sides, then you can go for the brick walls too. Then 7, steel of a smaller dia than recommended. Okay, when the whole scenario was checked out, then we have found out that okay, instead of 12 of the steel bar, we have got a 10 die of a steel bar in the columns, which should not be the case. Whatever the column it is, we should go for minimum of 12 dia. Even in the beams, 8 dia steel was being used, but if it was designed in that way, then it's okay. Otherwise, we should go for minimum of 10 of dia of steel. Okay, so guys, so that were the 7 possible mistakes with the collapsing of this whole boundary wall. Okay, and guys, if you are liking, like if you have liked this video, then hit the like button because that's free, and subscribe to my channel because again that's free and that will help me out. And if you find this useful, then share this with your friends and colleagues. And if you want me to make video on any particular topic, then and drop your suggestions in the comment box. I will definitely make a video on that one if that is related to the civil engineering. Okay, so guys, we will meet in the second video, and if you want to join some AutoCAD course, then you can find the details in the description. Thank you guys.